Today on AI Actually, token management, spend, and how to actually bring AI costs down.
Today is tokens. Who's got the tokens? That is the topic.
The price for ChatGPT 4 level intelligence has indeed come down, but I don't know that any of us are willing to put up with that level of intelligence anymore.
Smarter models compensate for poorly written instructions. We'll go through it and figure its way out, write custom things, and you get the result you want, but you spent much more than you needed to.
We've gone through a series of optimizations that have basically dropped that cost by about 33 times, not 33%, but 33 times.
Here we are again. Welcome back to AI Actually, number 24. Excited to have sort of a mixed crew here today, a little bit different team. We actually brought some, the real brain trust, the very smart people, Shanti Greene, Jake Barger, Chisam. I think Jake's new to the podcast, so this is his first time. We're gonna break him in on it.
He's never called us smart before, Jake. So we clearly
Jake has brought us all.
Clearly know who the smart person is that we brought this week.
We're breaking new ground.
We brought the smart team today. This is really it. Amongst this crew, with the three not named Jim, there is an incredible depth of experience in actually bringing to life real world agentic solutions, LLM powered applications, at scale in significant enterprises. And interestingly, and maybe this is fodder for a different day, in many cases around, we talk about ROI all the time, but around actual revenue producing applications as opposed to sort of the more mundane cost takeout story that's out there all the time. But today is tokens. Who's got the tokens? That is the topic. I think everyone's certainly familiar with the Uber story where their development team burned up their year's worth of tokens in a few months. And I think what's become apparent is, as the clients we're working with and what we all see in the press, that it's hard to sort of know what your spend is. How much are you spending? How much are you consuming? It's hard to forecast. It's hard to get your arms around it. Not all tokens are the same. And that's really the topic. And sort of, I think this is going to be a mix of maybe some practical advice on that front, and ideas and maybe some insights on some of the things we've seen, because we could call them widgets, we could call them whatever. If I think back to my econ days in college, it's sort of this ethereal thing, and it has a price, and the prices are all over the board. So that's the topic. Shanti, I'll turn to you sort of right out of the gate, and sort of maybe give your impression. Let's talk about sort of where the industry's headed. I think we are all thinking for a while that, the token prices are going down, and we were going to have essentially free intelligence. Not so sure that's the case right now.
No, and I think, token prices are going down in terms of the amount of intelligence per token, or maybe the intelligence per dollar. So the price for ChatGPT 4 level intelligence has indeed come down, but I don't know that any of us are willing to put up with that level of intelligence anymore. We've seen what more intelligent models can do. I can run more intelligent models or get more productivity out of models that I run locally than I could out of ChatGPT 4. So now we want more power. We want the ability to do more things, and the cost keeps going up. And I think that's where companies really need to think about, how are they using tokens? Where is that spend going? And what value are they getting? Which is not a place I generally like to be, thinking about cost optimization for like internal tools and utilities. I usually like to think about, let's just use the tools and put out the best possible things. I want to build as much stuff as possible. But now I really want to be considerate of, what are we building? And is this the right way to be building it?
Yeah, the one thing I would add to that, I agree fully with all of it, but I think there's a nuance that'll flavor this discussion a little as well, which is, as Shanti mentioned, that kind of price per unit of intelligence has been dropping pretty significantly, but the frontier keeps moving up to more and more deeper intelligence, obviously, and that remains a high cost. And and I think the whole industry is compute bound as well, which is adding to this problem. But I think for those that have followed AI for a long time, we noticed a shift, probably about 8 or 9 months ago, where, what was the frontier models that were coming out 8 or 9 months ago, right, in the November, December kind of time frame, really stood out as a big jump. An interesting thing is that usually takes about 8 or 9 months to take those frontier models and bring those capabilities into much lower cost intelligence. And I think that's something we're starting to see over the last month or so, actually, is some pretty capable models being released, from both the big labs like OpenAI and Anthropic, and also from open source competitors that are maybe not at the frontier on intelligence, but they're starting to reach that level that things were at 8 or 9 months ago, which I think that was, to me, like that point when you were like, wow, these things are really getting capable. So in a way that, but the frontier has obviously moved way ahead of that now. So there's still that tension between what is at the frontier and what can I source more cheaply, but that what you can get cheaply now is a lot better than it was 8 or 9 months ago.
Yeah, and to jump in there, you kind of see two different stories unfolding at different parts of the process. So as you look at model releases, there's this funnel that's emerging where at the very top, you have the frontier models going up in cost, and you have really intelligent models going down in cost. And when you're talking about cost per task, you're seeing that story go in different directions. Nobody conducting long form and complex research with open weight small models. It's always the highest possible caliber model you can put into that, because you're tackling really difficult problems. So these labs that are having all of these security events happen and these interesting things that frontier models are doing are always going to be pushing that. And then you have developers, the Uber example was mentioned, that are doing complex problem solving and always hit it with the absolute highest caliber that you can. But in terms of cost per task, you see this steady trickle downward, because the research that's gained at that frontier is then brought back in how to optimize for that lower level. So as we look at smaller agent buildouts, over the last month, we've seen massive strides in the releases of new DeepSeek and Grok models, and that's getting, and also some of the GPT releases as well with the Luna and so on. They're really getting cheap in terms of automating. And then you see things like micro VMs and Claude managed agents, which are just these isolated workspaces that can really drive that cost per task down, because now you don't have to worry about infrastructure costs either. You add 8 cents on top of your tokens, and then you have a free running agent to do whatever you want to accomplish.
Yeah, I think a piece that a lot of companies, people aren't thinking through properly is really about that model routing and understanding what's the complexity of the problem that I'm trying to solve. And is there a correct model size, model thinking set of parameters that I want to send this particular problem to? And it's not that that's a very easy problem, but it is the type of problem that a frontier model could help you solve. And it's like, okay, let me use up all of my thinking to figure out where should I be thinking about this and solving it? Because that's actually a small number of output tokens. Great. Put this in the right place, and half price, quarter price. A lot of the development style problems that we're thinking about start complicated, but then you build a plan. And once that plan is built, the execution of that is a set of very simple steps. Well, simple for reasonably smart models.
But routing's a complex animal. It's not as simple as, let me pick I know the intelligence level, let me pick the cheapest model for the intelligence level I need. There are a lot of different parameters that can drive how and why you would route it to one or the other. And I don't know that I've seen or heard of sort of anyone licking it, kicking that issue cleanly. Thoughts on that? Because I think it almost becomes a bespoke problem for each enterprise, and there's not a sort of universal set of answers that would apply across.
Definitely. And Jake's got some more detail on this, but one of the things, we were at the Anthropic base camp a few weeks ago, and they were talking about starting with their smaller models and then working your way up.
Yeah, there's a few interesting points there. Yeah, as Shanti mentioned, one of the most important things that we've been seeing pushed across the industry is that smarter models compensate for poorly written instructions. So if you give some vague prompting and then send a really intelligent opus or soul level of intelligence, then it will essentially go through it and figure its way out, write custom things, and you get the result you want and you're happy, but you spent much more than you needed to. Then when you put in the smaller model, the haiku or equivalent, it runs through it and it runs into issues. And you kind of think, well, I need to upgrade the intelligence, but rather saying that my instructions were underspecified. And so if you're able to get it work with haiku, then you're also going to have a more efficient opus pipeline as well. So that's why we're always trying to start at the bottom of the intelligence funnel and then move up only if we're forced to, because you end up saving money and you also make your instructions significantly better. The other thing with routing that's interesting that we're seeing this play out when we play with services like OpenRouter is caching varies wildly by provider. So there's certain providers that you can cache a lot, and with GPT, but maybe DeepSeek's significantly more expensive. And that input-output token is no longer a granular enough knob to know whether or not that provider is going to do your job. So, Jim, the point you made was that it was really specific to understand what you need to do for the task. How much memory do you have to have retained while you're solving it is also now this cost knob as well.
Oh, that's interesting. Yeah, that's a good one.
I mean, that can also, this is why actually that technique for routing can matter a lot as well, because, let's say I'm using a really intelligent model at front, and then it says, oh, I can do this with a simple, right? I can do this with a simpler thing, and I send it off to a lower model. Unless it's done right, unless it's kind of a consideration in your design, when you do that model handoff, you're getting a completely new, it's called KV cache, but you're getting a completely new cache behind that. Most of these models it's a very dramatically lower price if you're using the cache versus if you're not. It's just broadly a technique you should do for, regardless of what model you're using, that's a place for really dramatic cost reduction that we've seen. And so one cost of switching models is switching caches. And so you have to be aware of that impact. And that's why a lot of times, like if you can more, if whatever is making that decision on where to route, right, is made in the lightest way possible, which might be just like this type of task, before you hand it off to the main model that's going to do the work. That is an area to really look for depending on your task.
It seems like there's not a set it and forget it. Historically, so much of technology-driven solutions had an element of, okay, we're there, we got it. We sort of met the floor of what we wanted to deliver. Likely it was in some form of deterministic software. And, we figured out our database, we figured out our server, we figured out, all of that, and it's running. And this seems like it's dealing with the tokens, dealing with the routing, dealing with the level of intelligence, dealing with the cost optimization. It seems like it's a constant potential adjustment and tuning activity, and sort of presents maybe a different skill set that maybe than was available before or needed before, and just sort of an annoying ongoing activity to have to go through. And I don't get the sense that the model companies are landing with pricing structures and visibility to token consumption and the set of tools that you need as an enterprise or as a customer to sort of continuously optimize that solution. It's all a very vague handshake to me.
I think we're also, and the model companies, a lot of them, they weren't businesses, right? They weren't enterprises that had a business model and they understood what their costs would be, even the cost of development and what it takes to run all of that compute. So I think they're making it up as they go, as businesses have to do in the early days, because it's still really new and they're trying to understand what's adoption, who's going to pay. But the models definitely seem like like a leader follower also. Like OpenAI goes, we're going to charge $20 for a subscription. What do you know? All of the subscription, like we need a $20 tier. Like, okay, we're going to have a fancy tier. We're going to charge $200 for a subscription. All right, let's go to 200. And then at some point, Google was
But
like,
by the way, that kind
$249.
of the price signaling for airlines or similar. I mean, there's a long history of legal action associated with that kind of activity. I don't know that will ever come to bear here, but it's sort of interesting to think about. You know, I don't want to call it price fixing, but it is. Other industries have fallen on the government sword over things like that.
Yeah, I mean, I was gonna say even Moonshot with the Kimi model, their plan is like $19 or $20, and I'm sure that their costs are just on a different scale than Anthropic's cost or OpenAI's cost. I don't know what they are. I just know that they're probably different, but the price is the same.
Well, also, just to jump back to the set it and forget it point, because I do think that this is a fascinating problem that we see across industries and enterprises as you're building really complex agents that you get working as this crystallized version of all the things that worked at that time. And then the whole industry has this shiny object syndrome where all of these new models are coming out every second and a new harness version is released. How do you handle that constantly? There's a cheaper and more intelligent model that comes out by the time you've just gotten your pipeline running. So we talk about benchmarks and how to run that. But an engineer is constantly tinkering to make this a cutting edge solution. So the interesting part is where things like Claude managed agents enter the industry because they're trying to put standards around that. Latest harness, latest haiku. They try to start managing the testing for you. So that way you can get it working with the tier that you want and they can bring it forward. Whereas we are finding cheaper ways and more efficient ways to handle some things on the smaller, scrappier scale. You end up locking yourself into a model version and an agent harness version, and then you have to go and tinker with it again when everything around it has changed. So yeah, it's been really interesting to try and see what the industries are doing to keep up with that.
And I do think there's, I agree with absolutely that the general point of this is a constant challenge where you have to be constantly optimizing. Today's great answer is probably not a great answer in a few months. But I think you can put the right systems and processes around that so that that's a reliable process. So let me start with an example, kind of just go maybe on an example on something specific we're working on today and also show kind of the relatively dramatic results I think you can get when you apply the right processes to optimization. So we're working with an enterprise SaaS company today. We've built a series of AI agents for them. Where one of those agents has been in kind of an alpha type of stage testing with the early release customers among their customer base. And we're getting ready to release that to their full customer base, which is, 10,000 plus kind of users having access to this. So you're getting to that point where, and it's something that can be used quite a bit. So it's something where cost and scale and speed are a consideration. So the process that's worked and the just cut to the chase, we've gone through over the last few weeks, going through a series of optimizations that have basically dropped that cost by about 33 times, not 33%, but 33 times, right? So what was costing $1 now costing under, like 3.3 cents, right? So the approach for that, I think, is a repeatable process, at least for some tasks, right? So the first bit is when you're first developing these agents, the frontier models are very helpful. You often want to start with a frontier model to prove that the task can be done and how it can be done and what a really good result of that task is, right? And then once you have that, it becomes really an optimization challenge and a little bit of a hill climbing exercise where you can give another frontier agent, if you have the right telemetry and the right evaluation harness, you can now give one of the frontier agents a hill climbing exercise to optimize that task against lower agents. So the process we went through in this case, as an example, was we identified a series of potential lower cost models that we wanted to analyze against. First went through, we have, and very critically, what you have to have is to do this is a really strong evaluation harness. That means you have a set of, let's call them golden examples, right? Like, hey, here's a task I want this agent to do, and here's what a good result would look like. And then and then having a framework for pulling in all of the telemetry to identify that and go through it. And so we went through an iterative exercise, and I probably can't share the chart, but we have this chart showing through basically 10 releases of the agent with a particular model, its performance going from being dramatically below the frontier model's performance to being at the frontier model performance at 33, 1/33 of the cost and twice the speed. That's another thing that actually,
over what timeline?
As you do this.
Over what timeline was that sort of? Really?
Yeah, like a couple. Not a long period of. And when I say weeks, it's probably more like 2 weeks of optimization to do that. And what you find to do that tuning, think of it as like a manufacturing process, right? The first thing you got to do is figure out, how do I put all of these parts together and create something that works? And once you have that, then it's kind of optimizing each step along the path. And what you find is that there's, especially with these agents, one, starting with KV cache optimization, regardless of what, that's not between models, but that's a dramatic place you can go to make sure you improve performance. And actually that 33x improvement doesn't include that. But the next place is like your tools themselves. Normally agents have tools that can get called. Frontier agents will work really hard to figure out, how do I use that tool in the best way possible to get my answer? And they'll maybe do more thinking and experimenting and things along those lines to use it, make sure you can get the right answer from the tool. But a lot of times what you find is you can improve the tool and improve the instructions around the tool that the agent has and how to use it to just make it have to do less thinking.
Less thinking to pick the right tool.
Thinking, improving those instruction sets, improving the boundaries between tools so it doesn't call the wrong tool. A lot of times if you follow thinking path on this, an agent might eventually get the right answer, but it first called the wrong tool, right? And then it realized, oh, that doesn't work. Let me try this other tool, because the boundaries and kind of system instructions around how to, when to call which tool weren't in the best situation. There's a lot of those type of optimizations. But basically, with the right evaluation harness and telemetry, agents can run in the background optimizing this for you. And that's basically how we achieved it. It was, obviously there was a human driving this process, but that human was basically orchestrating an agent that was going through this process of optimization of the instructions, of the tools, of all of that as we climb that hill.
That reminds me a little bit of, try to get the name right, Sakana Fugu's model, which is basically multi-agent system as a model. So they're like, we can combine multiple frontier models, but make that transparent to the user. So you make one model call and it's doing some orchestration behind the scenes and doing some routing to make sure that all of the right tools are running. You don't have to think about Like, where is it being cached? Which memory is it using? That's happening in their system, and then it just routes the pieces to the right level of intelligence and calls the right models, and actually kind of gives you that model combination type system to get extra smarts for less total dollars.
And just to kind of tie this together too, because this resonates a lot with what we're seeing in different implementations, as well as some of these new models are coming out and agent harnesses that allow you to cut the cost by that much. The lower tier models allow you to see where points of ambiguity lie in your instructions. So you let them loose, and where they get confused is really useful information, because you can see all their logs and thought processes. And that discriminatory process that Stu was talking about, where you have a larger model that's saying, I see the agent getting caught here. How can I refine that? The other is really tying it together with what Shanti was saying with multi-agent systems. You need to manage your context really effectively. The two biggest things that will both slow you down and blow up an agent's cost is inefficiently managing your context. Every agent is born, it has to only be given what it needs to complete that task. And so when we do things like a big workflow, you spawn up a smaller agent with just the skills needed to do that. And that agent actually runs quicker because of it, because the tokens come quicker with less context. And you also save money on that specific subtask. Even though it's really nice to think that you're helping it by giving it a bunch of troubleshooting information, if you find that it's not running into the issues or invoking that part of the context, then you save yourself seconds of every single run by shaving that out. So really,
Actually,
like
yeah, that reminds me of another like framework shift in paradigm. So you can have your smart orchestrator who's watching and saying, I'm seeing you getting stuck. And then something we learned about recently was the idea of you've got your worker who understands I've gotten stuck and knows how to reach out for help. So rather than having somebody monitoring and saying you need help and stepping in, so you've got that process of always running and monitoring, you've got something that's not running, and the worker that is running reaches out and says, oh, I need your help now. Help me answer this complicated question. I've tried 3 times and failed. Goes to get the help, and that can be a good cost savings. It reaches to the smarter model only when it needs it.
It's like what we saw in development teams. That was like a big talking point, when you were hiring people, of when do you Google things and research yourself versus when do you ask at a senior engineer for help? Have you researched enough to ask a question, or did you waste a bunch of time? And you want that balance between agents as well, where it's like, okay, it tried to do its task. Did it burn a bunch of tokens getting stuck, or did it go back to the orchestrator to see if there's a broader thing that it's missing?
I had an old director who said, you're only allowed to bang your head against the desk for 2 hours before you're required to ask for help.
Right. It's always painful when somebody comes back after 4 days and you're like, I could have told you this 3.5 days ago.
And there's 2 techniques for that, and the right technique can also matter at scale, right? So one is kind of in process of the agent's operation. The agent says like, oh God, I'm stuck, right? And it escalates up to a higher level agent. Now the interesting thing is, if you're really optimizing downstream using lower thinking models that aren't as smart, they may also not be quite as smart to know exactly when to escalate without the right harness. You have to have the right harness for that. But the other thing is post, right, is having the right framework to evaluate like, what are the results that I got? Measure the results that I got. What feedback can I get, which can be an evaluation that can be as simple as human driven. This got a thumbs up, this got a thumb down, someone complained about this, put in a comment on where they got stuck. Or it can be an agent driven assessment of the work. But then you need a trace, right? So you then need to be able to say like, oh, the agent got stuck here, let me trace that. And you can get and that's where a lot of this improvement harness we've been working on goes, is it identifies poor performing runs, and then you send an agent to review the trace of that, and then say like, okay, well, what can I do that would have gotten a better result, right? Something that's closer to the golden eval standard that we have. And it starts iterating on, well, let me change this instruction. I noticed it got, caught up in this tool calling loop. Let me fix that. getting that sort of process, that sort of loop into your engineering cycle, right? So that thing that can happen is you can fix it so that on that run, it does it and it says calls for help and it gets the other agent and actually, but you don't want to lose the opportunity to make sure next time it doesn't have to call for help.
Hey guys, I'm going to force a topic change a little bit here.
Okay.
But we're going to stay in the same domain. There's no chance we get through this conversation without having some discussion about open weight, open source, self-hosted. Clearly, that's not the right answer for everyone. It may be the right answer for some, and maybe it might even make sense to give some clear definitions here because people get confused about the difference. And talk a little bit about scenarios maybe we're seeing where it might make sense. There is the grail out there, right? People, I'm running my own model, I'm running it locally. The inference costs are my compute, and that's it. But that's not going to give you frontier intelligence for sure. But where we are today is a lot different than where we were even a month ago, let alone 6 months ago. Who wants to maybe take this on out of the gate? Don't all speak at once.
We can talk about some of the things we've been experimenting with. We see a lot of promising things, and I think it is a really important point to set the stage with that. It's not for everybody. It really is how much the process that you're working with can tolerate being closer to the edge. There's a stability question that comes into play, and there's also a level of expertise question that comes into play as well, because your benchmarks have to be as good as your model infrastructure. So you have to understand when you're swapping these models out, what you're losing. And also something that comes in with open weights is how much context management can you get into. So an important curve that we have to draw when we're building out benchmarks is as you get up from that over 100,000 token context into the close to the 1 million that most models sit at, your tokens per second drop drastically on self-hosted models. And so we have to understand how much we're sitting in the upper echelon of context, and that will let you know what your realistic speed for that task is. The other piece is that really over the last month or two are the first time that we're seeing realistic performance of an agent harness by open weight models. Before that, you saw a lot of slowness and inconsistent performance, but with some of the newer Quins and DeepSeeks that are coming out, you're seeing you can drop them into a Hermes agent and have it do a task reasonably. And so that does seem very promising. But that gets into the problem that we drew earlier, where we were talking about where you have to manage that version tightly. So now you're responsible for the Hermes SDK version as well as the model version, keeping that up to date and managing your infrastructure. In return, you get this ownership, data security, and cost reduction that is unparalleled.
The other interesting thing about running open weight models, especially running them locally, is now you're in charge of all of the tooling around them and making sure that all of those tools are available and working, things that the model providers had been doing for you, making sure that all of the tools work nicely together, that you can actually reach out and take those actions, things like auto approval. That doesn't come out of the box with every model set up with just grabbing a model and saying like, okay, I've got a Mac, I'm going to run OMLX and see what happens. Like, that's great for just running the model. But how about all of the pieces around it that make it useful? So now I've got to think more about what harness do I want to use? Well, there's 20 open source harnesses. So am I going to go through and benchmark the same model in all the harnesses? Benchmark the same harness with 10 different models? So many choices need to be made that it can become overwhelming. Even if you're really into wanting to do that, your evaluation, your ability to make a reasonable comparison is going to be diluted by how many combinations you have to do.
Another thing that I think to think about on this is there's a lot of great models that are pretty small models. They could run on a MacBook. They can get some real tasks done, things along those lines. But when you see the news around, hey, here's a DeepSeek or a Quinn or other kind of really front model getting really frontier performance.
Yeah.
These are big models. The hardware it takes to run that stuff, it's is very non-trivial, hundreds of thousands of dollars to get some of to get hardware to run some of these models. There's some techniques like quantization and other sort of things where you can do with those models because they are open weight, but to reduce the hardware cost, but it has a cost in intelligence as well. But it's non-trivial, so you still wind up, depending on your use case, you got to serve that capacity. There are obviously a variety of ways to get that from the different cloud providers and other things along those lines. But it's I think sometimes people see that and they're like, oh, it's open weight, I can run it on my MacBook. Right. For a lot of great models in terms of they punch heavy for their weight class. Right. But
Yep.
Going for, a heavyweight model, there's kind of some basic limitations that happen in terms of the hardware that it takes.
And like a good rule of thumb is you take the parameter count, multiply by 2. That's approximately how much VRAM you need. And now you're looking at a 2.4 to 2.8 trillion parameter model to run one of the state-of-the-art open weight models. So you're talking 6 terabytes of VRAM. That's a very expensive proposition. And that's making some conservative assumptions about how many people will be simultaneously using it, to Jake's point. Like, all right, that's great for 1 user, 10 users maybe, if they're not filling up the context. We tested something locally with 30 simultaneous users all filling up the context, and we just watched the thing crash. And that was on beefy hardware.
Yeah. I mean, so it has meaningfully changed, or the landscape has meaningfully changed over the past month with the release of DeepSeek V4 Flash as a 300 billion parameter model that is showing exceptional performance in agent settings. And you can run that on a single GB300, a single Blackwell series card, one of the Frontier ones. But yeah, you don't get the level of parallelization and context token output speed that we need. So we're playing with optimizations there, but the cost has come down tremendously. I mean, you can host a single one of those cards for $10 an hour or so. And then if you're renting, and then you can, if you get 2, then you have that model at a much higher throughput setting. So then it starts to become reasonable. But you're entering into the space where you essentially need an AI infrastructure engineer to think about all of the trade-offs at that point. It's still the realistic for any developer team or business to embark on without a heavy research first.
Yeah, and you look at what's going on with memory pricing, you're like, okay, it's going to be 2 years before you could buy the amount of memory to even think about, like, all right, say I wanted 6 terabytes of VRAM and I was going to build something bespoke. That's going to be a super expensive proposition if you can even find the raw materials.
With this sort of this is a tinker's dream in some ways.
Yeah.
All I can think about whenever we have this conversation is if you're old enough to remember Ham Radio Guy was like the ultimate tinker in the garage.
Mhm.
This is sort of a rebranding of that for many people, and they love it. But in a world where we're actually trying to sort of actually deliver enterprise solutions that have an uptime, in the 999 space and can reliably perform and run an enterprise. And a lot of times there's sort of analytical solutions. That's one thing. But if we're talking about operational systems that are sort of part of the day-to-day workflow of the business, now you're on an even different level of performance requirement and uptime requirement. And it's sort of, it's not obvious to me yet where the needle to thread and where we're gonna go yet in terms of, or cross the bridge on building these kinds of solutions bespoke for a client. Maybe we're there, maybe it's going to take a little bit more time. The other thing that's become apparent over the last 2 years, the journey, is often we can start building to solve a problem, knowing that a few months from now, that problem will, the technology is going to be in a place where it does what we need it to do. So are we at a place where we would start taking that risk, or encourage our clients to start taking that risk in terms of open weight, open source, self-hosted, or hosted with pick your cloud service provider of choice? Are we there?
Yeah. I mean, I think you're making a big point there that people should realize, which is these costs are reliably going down over time.
If you look at the long enough curve, right, and not
It's
just what's
long
going
enough.
on in the
We're
moment.
also like, because things change so fast in this, when we say like a long curve, we're talking like, the last, like, that curve is still measured in weeks or months in some cases. I mean, I think it's still kind of, and there were a couple of model releases this month. I also think even the big labs now have kind of gotten the message that we need to bring costs, cost optimization is something to focus on. They're, from both the open labs and the closed labs, there have been dramatic improvements in this over the last month or so. And so you're going back to your main point is prove you can solve the problem. And if you can solve the problem, you can probably, between basically the Moore's law of AI saying, hey, this is going to come down over time, even if I don't do that much. And then if I go through some of these optimization techniques we've talked about, I can probably, typically once you find out how to get something done with the frontier model, you can figure out then how to optimize that down a lot. I think, it's the first thing to worry about is not the cost, right? The first thing to worry about
Can you do it? Can you
is
solve the problem?
what's the right way, what's the right way to solve this problem with AI? And then I think, but between time and optimization, reliably, that cost is going to come down pretty dramatically over time if you do the right things.
Yeah, it's knowing the context that each of the solutions fit into. If you are moving quickly and you want to, and you have a really highly technical staff, you can afford to think about, it's bringing the AI closer to you. Whereas if you're in a more regulated environment, enterprise grade reliability, then you start talking about managed solutions. If you're so regulated such that your data cannot exit your system whatsoever, then you go full circle back into open weight models. And you kind of need to be able to recognize the pattern that you're seeing and where these tools fit into. But the really encouraging thing is that over the last month, as Stu mentioned, we've seen costs come down. We've also seen model releases come out that are more intelligent. And we're seeing kind of flourishing pieces at all ends of the spectrum. Models are, they're getting more intelligent, but they're also, intelligence itself is getting cheaper. So that's really,
as consumers, businesses, and other people that use these technologies, we're benefiting from the fact that this is competitive as heck. And it does seem like, there might have been an open question like months ago, like, wow, are the frontier guys going to get so far ahead that no one ever catches up or something like that? And maybe that still happens. But I think what we're finding is there's a bunch of different players being, within, at least a 6-month window of each other. They, maybe they're lagging the frontier labs, but reliably there's strong competition from multiple providers. And I think that's good for the, for all of us trying to get value out of these tools, because it really, I think, continues to keep a lot of pressure on everyone, on the companies providing these models to keep bringing that cost down.
I think from a business economics standpoint, if you're in a business where you can solve the same problem in the same amount of time, you can see your cost to solve that problem decrease and your margins increase. But reliably, people are like, well, what if I solve that problem faster? Or what if I solve that problem and another one? So if you can afford to have that static piece and keep those two pieces, like amount of time and problem, yeah, you can bring that cost way down.
Hey, Jake started to brush up against a sort of related topic of AI sovereignty, and particularly as it relates to regulated organizations or organizations that are highly concerned with their data and data protection. And there's a whole topic here around zero data retention and what's really in those agreements. I'm going to press pause on that one. But I think because it's huge, it's worth its own discussion, and we're going to kick that down the road to a future. I know we're sort of bumping up against the hour here, Guys, sort of, so many of our clients and the companies we work with are at various places on the journey. We live inside the AI bubble every day. And sometimes we think we step out of the bubble in a conversation with someone and we realize I'm still inside the bubble. And it's hard to sort of find the limits of it until we run into some of our clients who, you just want to shake them and say, whoa, 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 wake up. This is happening. And you're surprised at where they are. And sort of giving advice on this topic is difficult because people are at such different places in the journey. If you were going to sort of bring it around here to maybe a couple key points around token management, token spend, token usage, what would be sort of your big takeaways? I'm giving you all a chance for a big finish.
I mean, I think focus first on finding real valuable solutions with these agents, and then good engineering techniques, which really require having a good way to evaluate yourself and good telemetry to review what is happening. I would have high confidence that, like I said, you can optimization will pay off, especially at large scale. You can make dramatic improvements. Time will help as well. But the biggest thing is getting this stuff to solve, right? To solve your business problems. And I think the difference between what you can do, I mean, if you are in that bubble, just the difference between what you can do now and what you could do in January is pretty nuts.
Amazing.
And, and so I think a lot of people who maybe, developed priors, a year ago around what these things were capable of, if you're not keeping up day to day, it's really hard to appreciate how much more complex problems are capable today. And I don't see anything that says that's not going to be true a year from now. Looking back, where we're at today, I think will look primitive. Again, still in another year.
I would throw out that looking at token prices, there are still problems that are not cost effective to solve, where the solution is more expensive than the value it would provide. But that doesn't mean you shouldn't reevaluate that every new model release. When models get smarter, the price for older models comes down, the amount of compute needed might come down, or you no longer need a frontier model to solve your problem. Now an open weight model can do it. But it still happens that there are problems I want to solve that don't provide a significant amount of ROI, so I don't solve them, but I keep looking at what will the solution cost, because one day it will cross that threshold and I'll finally be able to read all of my newsletters with an agent.
Yeah, and just to kind of, I think, distill down a lot of the things that we're seeing are successful, the patterns are use agent sandboxes, doesn't matter if it's local Docker or a cloud service. Agents thrive when they can write Python, grep, and actually play with the things around them in a free space. That's what they're trained to do. Start with intelligent models to improve or to prove out that the entire pipeline is possible and you have a target. Move to lower intelligence to immediately run with your cost optimization. Think in skills and tools and understand the difference really well between those. Skills are magical context management packages, and those are your biggest lever for refinement in terms of speed and context management outside of the model itself. And then run with that. Think about things like memory and when to elevate as more granular knobs, when to cache and make sure your agent's using that. And you would be shocked how many problems you can solve and drive the cost down rapidly with that sort of approach.
Awesome. Guys, I appreciate it. Thanks so much for joining, Jake. Maybe we'll invite you back again at some point in the future to be part of the crew. Shanti, Stu, I appreciate it. And that's, I think, a wrap on episode 24.
All right. Thanks, guys.
Thank you. This was fun.
Thanks, guys.